Hey guys, how are you doing today? Trying to do a little bit of a different app for doing my video, and I want to let you know that I want to see how you all like it and see how it comes out for you. So give me some feedback on it and let me know what you think. So what I've done is I've taken a copy of the warm-up that we would be doing for this last day, okay? And I'm going to go through these two problems with you. Okay, first it says, a recent study showed that the average blood donor stops after giving 12 pints with a standard deviation of 2.3 pints. If the Red Cross wants to reward the top 5% of blood donors, how many pints would they have to give? Well, first things first, I need to draw my picture. So I'm going to draw my picture. Okay. And here, this is 12. Okay, and then I want the top 5%, so I'm going to, oops. Sorry, trying to get used to the program a little bit. I'm going to draw a line here, and this filled in here is going to be 0.05. So what does that mean? Well, that means that everything that goes to the left of this is 0.95. So what I'm going to look for is I'm going to look for 0.95 on my blue sheet. And when I do that 0.95, I end up with 1.65 as my z-score. Well, if that's my z-score, then it's just simply 1.65 equals x minus 12. Goodness gracious. Yeah, evidently I didn't pause. Oh well. So you got to see all that fun stuff. So I have x minus 12 over the 2.3. And if you do the math, you get x equals 15.795, or in other words, you have to have 16 pints if you want to be in the top 5%. Okay? Okay, so problem number 2, it says the average family household income is $46,550 with a standard deviation of 3,125. A poll was being taken on how the average blue-collar worker feels about the stock market. The poll only wants the middle 30% of incomes. Assume a normal distribution. What would the limits on the income be? Well, again, the biggest thing that you can do and the best thing that you can do for yourself is to draw an accurate picture. Here's your mean, okay? In this case, the mean is 46,550. Okay? And if I want the middle 30%, that means that this and this are both going to be 0.15. So what does that mean for these two limits here? Well, remember the middle is at 50. If this is 0.15, that means I'm looking for means I am looking for, stop it, 0.35 from here down. Okay, so that, and then from here down is 0.65. Why? Well, if from here to here is 0.15, and then from here all the way over is 0.65, then it's pretty straightforward that this is 0.65. So if I use my blue sheet, I end up with this area, this z-score being negative 0.39, and you should know by now that because of symmetry, that this z-score is going to be positive 0.39. So then all I do is find my x's. So I have negative 0.39 equals x minus 46,550 over 3,125, which gives me an x value of 45,331.25, because this is money. Okay. And then the other one is positive 0.39. Same thing, x minus 46,550 over 3125, and I get an x value for my upper range of 47,768.75. Again, guys, these are just review problems. These are things that you should be able to do on your own without much help. Okay, so let's go ahead and do just a couple more problems. Okay, so we now have our lumberjack problem. Lumberjacks eat 12.2 flapjacks per sitting on average if with, oops, I forgot. I didn't get part of the problem. Sorry about that. With a standard deviation of 4.7. And it says if a group of 30 lumberjacks sit down to eat, what is the chance that what chance is there of them averaging over 14 flapjacks each? Okay, so the sigma for this problem equals 4.7. Didn't get that in there, sorry. All right, so draw our picture. This is 12.2. And this is what? This is 14. And we went over, so we're going to shade to the right. Okay, so what's the z-score for that? Well, the z-score for that is going to be 14 minus 12.2 over 4.7 divided by the square root of 30. Why is it the square root of 30? Because we have a group that we're doing. We're not doing just one lumberjack. Okay? So if we do that carefully, we end up with 2.10 as our z-score. And then, again, that gives us a point 0.9821. Now, it's not a 98% chance. Why not? Remember, that's everything. This number is everything to the left of 14. To the right of 14 would be 1 minus 0.9821, which gives a final evaluation or a final total of 0.0179, or a 1.79% chance of it happening. Okay, last problem for today. It takes an average lumberjack 97 seconds to chop through a 1 foot diameter tree with a 6.9 second standard deviation. Big Max claims he can do it in under 75 seconds. Do you believe him? Why? Okay. Well, again, draw your picture. 97 is the mean. Here's Big Max at 75. and he wants to do it in under, so it's to the left. So what's my z-score? Well, z equals 97 minus 75. What'd I do wrong? It's always observed minus expected. So I want to go back, and it is actually 75 minus 97 over 6.9. Now, why don't I have to divide this by the square root of a number? Because I'm only doing Big Macs, so it's only 1. All right, so I get a z-score of negative 3.188. Believe it or not, that's on your chart, barely. So that gives me a probability point 0.0007. So there is a less than a 0.1% chance of this actually happening. Do you believe him? I don't. N-O. Max B. Fibbin. Anyway, you know, the problems I'm going to give you to go along with this are basic, straightforward review problems, and then we'll get to the test problems sometime soon. All right, guys, enjoy the rest of your day.